Is it visible? Tarni? Thank you, ma. Thank you. Okay. So, good evening, one and all. Let's see today's session. So, we are going to see on the topic of security at the transport layer. Okay. So far we have seen the security at the application layer. That is, we have come across email security. Okay. And today we are going to see the security that can be provided at the transport layer. So we'll be using two types of protocols. One is SSL, that is secure socket layer. The other one is transport layer security, that is TLS. So we are going to see these two, okay, in this session. So the objective of the session is to make you known about the security at the transport layer. That is knowing about the two types of protocols that is applicable at the transport layer. Okay. So which will be providing security services at the transport layer. Okay. With the help of these two protocols, SSL and TLS. The outcome of the session, the students may be able to understand the concept behind the security at the transport layer. Okay. So the main objectives is to discuss the need for security services at the transport layer of the TCP/IP model, that is internet model, and to discuss the architecture of the secure socket layer and the architecture of the TLS, and to compare these two protocols. Okay. So these are the outlines of today's session. Let's start with the introduction about the secure socket layer, and with the history and what are the versions involved in SSL. So why this SSL exists so far, and we'll be seeing about how to locate or where the location of SSL and TLS is fixed in the TCP/IP model. Okay, and we'll be seeing what are all the services provided by the SSL, and let's have a walkthrough what does this SSL do. Okay, and we'll move on to the architecture of SSL and what are the goals provided by the SSL. Okay, and we'll see the step-by-step process of how the SSL works. Okay, next we'll be going with the introduction part of the TLS, transport layer security. Then we'll be seeing why do we need this TLS in the transport layer, and the working of the TLS, and what are the benefits provided by the TLS. Okay, with this we'll wind up. Okay, let's see SSL certificate. So SSL is an acronym for secure socket layer. Okay, so this is like this certificate is like a passport. So with the help of the passport, you can go by visiting any countries, okay, apart from the our state. Okay, so where in which SSL serves two purposes. So the first purpose is it it permits to access the encrypted informations. Okay, so through with the help of the public key infrastructure. The second purpose is it helps authenticate the identity of the owner of the SSL certificate. So who is owner of this particular certificate? It will authenticate it. Okay, and SSL is widely used in websites. Okay, so no matter what kind of the website it is whether it can be a blog or it can be a shopping portal or anything, any portal. Okay, if you want to visit any websites, you can go with that is SSL will be providing security for the secure transmission between the client and the server. Okay, so you might have noticed in the URL, that is some of the websites will be having either HTTPS, that is hypertext transfer protocol secure, or you might have noticed like HTTP. So S is representing the secured website. Okay, so the difference between the two is only the S. at the end of the protocol. Okay, so HTTPS indicates the website is a secured, which means that it is secured, which is provided by the SSL certificate. That helps in securing the communication. That is, you can have the secured communication between the two parties, that is client and the server. Okay, so that happens between the web browser and the website you are visiting. So for this purpose, you will be using the SSL certificate. Okay, so SSL is one of the security technology. Okay, so which will offer the secure transmission or connection between the web server and the web browser. That is, client, web browser is nothing but the client, and the web server and the client. Okay, so it assures that the data transfer between the web server and the browser it should be a secured one. Okay, so by providing the SSL certificate with the help of the HTTPS secured. Okay, so you might have seen this lock icon in your browser. So if you are using HTTPS, you might have noticed this lock icon in your browser. So it shows that you can the transmission or the communication between the server and the client will be a secured one. Okay. Okay. So SSL, we'll see the main concern about the SSL is a secure socket layer, and this is a standard security technology for establishing the encrypted link, that is secure link between the web browser and the web server. Okay, and through this link you can ensure that all the data passing through this link between the web server and the browser remain private. That is, no one can access these messages or datas. That is, no intruder can access these datas. Okay, so let's see the history, how the SSL emerges. Okay, so Netscape Corporation developed this secure socket layer protocol, that is SSL, in the year 1994. Okay, so mainly it was developed to provide security on the internet. Okay, so this was originally developed for securing the web browser and the server communications. Okay, and we'll see what are the versions available with this protocol SSL. Okay, so there are several versions of the SSL protocol defined. So the latest version of SSL is nothing but the TLS, Transport Layer Security Protocol, and this is based on the SSL 3.0. That is, you are having so many versions in SSL, that is version 1.0, version 2.0, version 3.0. Okay, so after the SSL version 3.0, so the updation of the version is TLS emerges. Okay, so after SSL version 3, TLS version 1.0 emerges. Okay, so TLS 1.0 with the SSL version 3.0 is compatibility. Okay, so why we are going for SSL? Why does this SSL exist? Okay, so you can have look through this picture. So in the first picture, the sender will be sending some message to the receiver. So the intruder may access those messages. Okay, so that is, no security is provided here. Okay, so coming on to the next picture, so the sender is encrypting the message and encrypting using the public key, and the receiver will do the decryption process with the key. Okay, that is, the plain text is encrypted and it is converted into ciphertext. Okay, and this ciphertext will be hacked by the intruder. The thing is that, so in the second picture, you might notice that this message is hacked. Okay, that is, no integrity is preserved. That is, message integrity is not preserved. So integrity is means that the information is not transmitted in a secured manner. Okay, so some alteration is done in between the transmission from sender to receiver. So in the first picture, security is not provided. The second picture, message integrity is not provided. So for this reason, SSL comes into picture. Okay. So here you can see the same previous slide was depicted here. So authentication of the server, that is, how does the client know who are all dealing with? Suppose Alice and the Bob are transferring messages between them. So the intruder is dark. So he is a person who spoof it. Okay, spoof the messages. So authentication is not provided. So for that purpose, and also the second thing, information or message integrity is not provided. So for these two reasons, we are going with the SSL certificate. Okay. So integrity means how do we know the third party has not altered the data or the information or in between the sender and the receiver. Okay. Okay. So let's see where we can locate this SSL in the TCP/IP model or the internet model. So the first layer is that is the higher layer is application layer. So there in that application you can the protocols used are HTTP, SMTP, POP, yes, and secured application protocols are HTTPS, SSMTP, that is secured single mail transfer protocol. Then POP is secure post office protocol. Okay, so these are the protocols, SMTP and POP or the protocols used to transfer the mail from sender to, that is from sender to receiver. Okay, and the numbers indicates the port number through which the messages can be passed. Okay, so under this application, between the application layer and the transport layer, you can have this secure socket layer protocol. Okay, so here you can see, so in between the application layer and the transport layer, that is TCP and IP or the protocols used at the transport layer, in between these two you can place this SSL or the TLS. Okay, so these SSL and TLS belong to the transport layer. Okay, so which will be providing the end-to-end security for the applications that use the TCP protocols, that is reliable TCP protocol. Okay, so mainly we are using this SSL for the security services provided by the edge. Okay. Okay, so this was developed by the Netscape in the year 1994. So it was designed to provide the security services and compression services to the data which is generated from the application layer. Okay, and whatever the data received from the application will be compressed, and this compression task is optional one, and after that receiving the data from the application layer, it will be compressed and signed and encrypted before it moves to the next layer, that is transport layer. Okay, and what are all these services provided by SSL? We'll see one by one. There are 5 services provided by SSL. The first one is fragmentation. So what I mean by fragmentation is the given data block, data will be divided into blocks of 2 power 14 bytes. Okay, and compression means after the fragmented data, it is going to enter into the compression with the help of applying the compression algorithms. So here you will be using lossless compression methods, and this compression service in SSL will be an optional one. Okay, and the next service is message integrity. Okay, so to preserve the integrity of the data, SSL will be using the hash function to create the MAC, that is message authenticated code. Okay, And the next service is confidentiality. So to provide the confidentiality, the original data and the message authentication code, these two will be encrypted using the symmetric key cryptography algorithms. Okay, so already we have seen symmetric key cryptography algorithms. They are DES, triple DES, double DES, AES. So all the things we have seen, algorithms we have seen already in the previous sessions. Okay, so using this algorithms, both the data, original data and the message MAC are encrypted. Okay, and next service is framing. So what do you mean by framing is that the header part will be added on to the encrypted data. Okay, that is encrypted payload. Okay, so this payload then passed then to the next layer, that is transport layer. So from the application layer, it process fragmentation and compression will be carried out. Then hash function algorithm will be supplied to it. So then symmetric key cryptography algorithms will be used for encryption. After that, the header part will be added onto the encrypted data. Then it will pass on to the transport layer protocols. Okay. So we'll have a quick walkthrough about the SSL. So what are all the steps carried out by SSL? We'll see. So the first step, the browser, that is the client, will be connected to the some website. Suppose if you're going to visit any website on a browser, the browser connects to some website that will be activated from the web server. Okay, so the client accesses the website. Okay, so the web server will respond with the certificate. So that certificate is SSL certificate. Okay, so the web server will respond with the certificate as well as the public key of the server will also send to the client. Certificate as well as the key will be sent from the server to the client. That's the second step. Okay, and coming on to the third step, after receiving the key, server's public key and the certificate, the client verifies with the CA. So what do you mean by CA? It's a certificate authority. So certificate authority will be the agency which issues the certificates. So the client can verify the certificate authority whether the matches or not. Okay, where the client verifies the certificates with the CA, that is certificate authority. Okay, so after verification is done, the client will be sending the random key to the server. So this random key is useful for encryption. Okay, and step 5, after all the communications are encrypted using this random key, that is both by the client and the server, the process ends. Okay, so far we have seen the just rough walkthrough how does the SSL is created, SSL certificate is created. We'll see in a brief manner in the following slides. Okay, so all the data will be encrypted with the help of the server's public key and decrypted with the help of the server's private key. Okay, so there are two, the randomly generated key was randomly generated by the client. So the client is having the whole responsibility of creating the random generated key. Okay, so with that key, encryption will be followed with the help of the server's public key. Okay, so here the keys will be known by the client and the server. Okay, unless no one can share or else no one can know these keys. Okay, so therefore encrypting the data with a random key secures the data from the intruders. Okay, so the random key generation plays a major role here. So this was generated by the client. So with that random key and as well as the will move with the encryption part without knowing that is no intruder can access those random key. Okay, so this random key will be providing security for the secure transmission is carried out with the client and the server. Okay. Okay. So the SSL uses public key schemes. So each client and server pair will be using two public keys and two private keys. So two public keys will be used, one for the client and one for the server. That is, client will be using one public key and the server will be using one public key. So that is, client browser will be using this public key will be created when the browser is installed on the client machine, and the server's public key will be created when the server is installed on the server hardware. Okay, and two private keys, one will be used for the client browser and another will be used for the HTTP server. Okay, see here, this SSL is most widely used protocol, and this SSL will be coupled with the HTTP protocol, which is a protocol used in the application layer, which secures the internet, that is web, and uses the, you might have seen, HTTPS URI scheme. Okay, so this SSL version 3.0 design is divided into two protocols. So one is the handshaking protocol, the other one is the record protocol. Okay, so here we can go through the architecture of the SSL. So in this, you will be seeing SSL handshake protocol. So four protocols are used here. So the first one is SSL handshake protocol. The second one is change cipher specification protocol, and third one is SSL alert protocol, and HTTP is your application layer protocol, and the next one is SSL record protocol. So coming on to the SSL, it has four protocols: handshake protocol, change cipher specification protocol, alert protocol, and record protocol. Okay, you'll see one by one. The same thing is depicted in the next picture. Okay, so in the SSL architecture, you'll be seeing SSL session as well as the SSL connection will be provided. So coming on to the session, it is session, this SSL session will be created between the client and the server as an association. Okay, and this session was created by the handshake protocol. Okay, and which there is a need to define the a set of cryptographic parameters. Okay, and this SSL session may be shared by the multiple SSL connections by using the same session symmetric key. So coming on to the SSL connection, it will be a peer-to-peer communication link between the client and the server. Okay, and this is associated with the version 1, that is with one SSL session. Okay, this connection is associated with one SSL session. Okay, so the next thing is record protocol. So among the four protocol, SSL record protocol is one of the protocol which provides confidentiality and the message integrity. Okay, so using some symmetric encryption algorithms with the shared secret key, so that was defined by the handshake protocol, confidentiality is provided. So here the message will be compressed before the encryption process. Okay, so what are all the encryption algorithms used are IDA, RC240, DES40, DES, triple DES, Fortiza, RC440, RC4128. Okay, coming on to the message integrity, which will be provided, this integrity is provided using a MAC, that is message authentication code. Okay, so this will be created with the help of the shared secret key and a short message. Okay, And the next protocol is alert protocol. So mainly this protocol is useful for mentioning the error messages, that is warning message or giving some alert to the user likewise. Okay, and it conveys the SSL related alerts to the peer entity. Okay, that was the job of this alert protocol. Okay, so the specific alert may be unexpected message, or it can be a bad record message authentication code, or it can be a decompression, a failure, or handshake failure. Likewise, what are all the actions going on? If some abnormal things happen, this will be indicated to the peer entity with the help of the alert protocol. Okay, next the fourth protocol is handshake protocol. That is, we are seeing a handshake protocol, cipher, chain cipher suit protocol, then record protocol. The other one is alert protocol. Okay, handshake protocol. So this allows the client and the server. So already we have seen TCP handshaking protocols. So how the TCP established the connection before transferring the data between the client and the server. Likewise, SSL also provide the handshake system. Okay, so this allows the server and client to authenticate each other. So I am the client, I am going to send the message to the server. Likewise, they are going to introduce themselves, and after that they can after confirming or establishing the connection between them, they will be transferring the data likewise. Okay, and handshake protocol is also used to negotiate what are all the encryption algorithms, MAC algorithms used will be selected. Okay, so among the encryption algorithms, the client will be sending the request to the server. So these are all the encryption algorithms what we can go for choosing the particular encryption algorithms to get secured transmission. Okay, and the next thing to negotiate the cryptographic keys to be used. Okay, so there's a series of messages in so many phases that is going to be happen between the client and the server. So first they will be establishing the security capabilities between the client and the server. Next there will be a server authentication and the key exchange between the client and the server. Next, client authentication and key exchange phase. The last phase, fourth phase is finish. Okay, we'll be seeing each and every phase in a coming slides. Okay, so what are all the components involved in SSL architecture that we have seen in the previous slides are SSL handshake protocol, record protocol, alert protocol, and chain cipher specification protocol. These are the four protocols which took part in the SSL architecture. So what is the purpose of handshake protocol? It is negotiating the what are all the encryption algorithms can be used, and what are all the parameters to be set. Okay, and what are the key exchange algorithms are there, and what are all the server authentication process and client authentication process will be done with the help of the handshake protocol. Next, coming on to the record protocol, and do the fragmentation, that is dividing what are all the services provided by the SSL that we have seen: fragmentation, compression, authentication, integrity, protection, encryption. So all these will be provided by the record protocol. Okay, and alert protocol will send the error messages, some alert warnings to the peer entities. And SSL chain cipher specification protocol will, it's like a single message that indicates the end of the SSL handshake. That is, the handshake process was over. It is indicating the finishing process of the transmission of the data. So for that purpose, we are using the SSL chain cipher specification protocol. So these are the four main protocols used in the SSL architecture. Okay. So mainly the SSL is meant for providing confidentiality and integrity and authentication. Okay, so that is confidentiality means the data being transmitted over the internet needs some confidential, that is some secret messages or confidential messages will be transmitted. So for that we can go with the SSL certificate. In other words, that is people do not want their credit card numbers, account details or account login details, password or personal information need not to be exposed over the internet. So some confidentiality to be maintained over the transmission. Okay, so integrity protection means the data uh, should remain integral, which means that once the credit card details or amount to be charged to the credit card have been sent, the hacker sitting in the middle cannot change the amount. That is, no more alteration in the data should be carried out. That is integrity protection. Authentication means, so client authenticating the server and server authenticating the client. Okay, so we'll see how the SSL works. Okay, so encryption is carried out with the help of the encryption algorithms like symmetric key cryptography algorithms, DES, RSA algorithms. Okay, so these are the algorithms used for encryption part. Okay, and this SSL will be sent between client and the server through the certification. Like certification means like verified by the signature. Okay, so see here how it works in browser HTTP. Okay, you can see www to the web client will be using the browser to visit some website like www.aiub.edu. So here you can see it is not having any yes along with the HTTP. Okay, next you can see HTTP yes. So in this right corner you can see a lock icon. So this means that you are visiting, the client is visiting the secured website. Okay, so Gmail is a secured website. Okay, and you can see this varcityadmission.com. So this is the site which provides some message. See here, the site security certificate is not trusted one. So it's not a original one. Okay, that's the meaning. Okay, so certificate means SSL certificate is used mainly for authenticating the websites. Okay, and this certificate, SSL certificate, will be issued by the agency called Certificate Authority, that is called CA. So this CA will be containing, mainly contains, or the certificate contains public key and the digital signature. Okay, so here at the right side you can see the certificate. It provides the details like serial number, signature algorithm, like SHA. Okay, and issuer, who is the issuer, it is the certificate valid to all these data will be included, and what is the subject and what is the public key used for encryption is RSA, and the constraints. So all these will be provided in this SSL certificate. Okay, and hashing will be done. So hashing, it is a process that compresses the text to a single number. Okay, so hashing is that is by applying hash algorithm like message digest 5 secure hash algorithm. All these hash algorithm will be used in this SSL certificate with the help of the handshaking protocol. So the data transfer will be of two types. One is asymmetric data transfer, the other one is symmetric data transfer. Asymmetric data transfer will be used in handshaking, that is two keys will be involved. One is a public key, the other one is a private key. So these two keys, public keys are used to encryption, are used for encryption process, and private key is used for decryption process. Symmetric data transfer means it is used in the application data transfer. Okay, and the same symmetric means it's a private key, and the same key will be used by both the parties, sender and the receiver. That is, for encryption and the decryption, the same key is utilized. Okay. So here you can see the handshaking. How does the handshaking is carried out between the client and the receiver? Okay, that is server. Okay, so the client will be sending the client hello message. Okay, so uh, so the random number will be sent, and the selected cipher suit, that is, what is the encryption algorithm to be selected, that is, the preferred encryption algorithm will be sent by the client, and the selected protocol version and certificate on what is the selected, sorry, first thing, what are all the supported or uh, cipher algorithms, that is, encryption algorithms available, that will be sent by the client. Then server will be responding to it by selecting the corresponding encryption algorithms, protocol versions and compression methods. Okay, so after sending client hello by the client and server hello by the server, so some establishment has been carried out. After that, the server will be sending hello done. Okay, then the client will be exchanging the keys to the server. That is, the session key will be generated. That is, random key will be generated by the client and sent to the server. Okay, so with the server's public key, encryption will be carried out along with the random key. Okay, then change cipher specification is indicating that the handshaking was finished. Okay, then the application data transfer will happen after the completion of the all these process. Okay, we'll see one by one in a clear manner. That is, see here, client hello is sent by the client, and server hello is sent by the server. Okay, then in the phase 2, server may send the certificate to the client. Along with that, the key exchange is also carried out, and request certificate will also be sent by the server. Okay, and you can see certificate from the server side, server key exchange and certificate request and server hello done. All these will be done in this phase 2. And coming on to the phase 3, client will be sending the certificate to the server, and client will be exchanging the keys also. Okay, and the client sends the certificate if requested by the server, and client sends a key exchange also. Client may send certificate verification also. That will be, client verification will be done by at the phase 3. After, in the phase 4, the chain cipher suit end with the finishing the handshake protocol. Okay, so client will be acknowledging that is the process was over, and server will be executing chain cipher specification protocol, stating that it has been done, it has been finished. Okay, see here, the same thing is depicted in this picture also. So first, the client will be sending the supported ciphers, means encryption algorithms, and random key generation also. Random key will be generated by the client. After receiving this all the things from the client, the server will be selecting all the encryption algorithms, random key, and the certificate will be issued to the client. Okay, and in the third step, encrypted master secret will be done. Excuse me. Okay, so in the fourth step, both the client and the server will be computing the keys. Okay, so in the fifth step, the MAC of the handshake messages will be exchanged. Okay, MAC means that is message authenticated code will be sent by the client, and server also will be sending the MAC of the handshake messages. Okay, so these are the 6 steps carried out in handshaking. Okay, see in words, that is the client sends the server. So that is the first process. The client will be sending what are all the list of algorithms it's willing to support along with the random number. So this 2 will be given as input to the key generation process. Okay, this was the first step. Second, the server will be choosing the encryption algorithm out of this list and sends it back along with the certificate containing the service public key. Okay, so with that public key, the certificate also provides the service identity for the authentication purposes, and the server supplies the random number also, which is used as a part of the key generation process. So after receiving that, the client verifies the service certificate and extracts with the service public key. Okay, and the client then generates the random secret key that is called as pre-master secret, and with this pre-master secret it goes with the encryption process using the server's public key. Okay, and sends the encrypted public key to the server. Okay, so now the client and the server independently compute the encryption keys as well as the MAC keys from the pre-master secret, and the client from the pre-master secret, and the client and the server's random values. Okay, next the client will be sending the message authentication code of all the handshake messages to the server. Next, the server will be sending the MAC of all the handshake messages to the client. Okay, so here the SSL connection will be divided into 2 phases. One is the handshake phase, and the other one is the data transfer phase. Okay, so during the handshake phase, the client and server will be agreeing on the set of algorithms. What can be the algorithms can be adopted for the encryptions, key exchange, hash algorithm, likewise. So it will be deciding during the handshake process. So after that, the client and server will be establishing the set of keys also. First, algorithm will be decided by both the client and the server. Next, the keys will be the keys will be generated by the client and the server. Okay, the server optionally authenticates the client. Okay, so after the handshake was over, the data transfer will happen. Okay, so data transfer occurs after handshake is complete. So the data along with the message authenticated code is encrypted using the secret key. That secret key was randomly generated by the client. Okay, so each data fragment has a record header. So here you can have suppose A and B are going to transfer any message. Okay, so the key so generated using the RSA, Diffie-Hellman, and cipher means that is encryption algorithms used are DES, triple DES, AES, RC4, and the hash algorithm used are hash authenticated code, that is MT5, and HMAC means hash based message authenticated code, SHA is used. Okay, so these are the algorithms used for key generation, for encryption and hash algorithm. Okay, we'll see overall process. Okay, see here. Suppose the websites, whatever the websites that the browser is going to visit, that is client is going to use that web browser, the websites that deal in e-commerce must have the certificates for authentication. So that should be installed at the server. That is, this SSL certificates will be provided by the server. Okay, and it will be transmitted to the client. From the server, the SSL certificate will be reaching the client for authentication, and the client will be do the validation process with the help of the CA. That is certificate authority public key. Okay, see this picture, you can have the client accessing the browser, which will be sending the request for the secure session with the server mission. Okay, so the server will be sending the certificate which will be signed by the CA, that is certificate authority. Okay, so this secure socket layer protocol is used mainly for the web communication. Okay, the latest upgrade of this SSL is going to emerge as a TLS, that is transport layer security. Okay, so both will be having more or less same structure like SSL. What is the architecture we have seen for SSL? That is the same architecture will be used for the TLS also. Okay, so the first phase, establishing the security capabilities. Second phase, server authentication and the key exchange will be happen. Okay, and third phase, client authentication and key exchange will happen, and final phase, finalizing the handshake protocol. So what about the first phase, that is establishing the security capability? So here the client and the server will be announcing their security capability, that is both will be choosing the what are all the algorithms preferable from the list of algorithms. Okay, that both the client and the server can go with selecting the algorithms that are convenient for both the parties. Okay, so two messages are exchanged. First one is client hello, and the second one is server will be sending the server hello. Okay, so the parties agree upon the particular compression method also. So what can be the compression method can be done. So compression algorithm is an optional one. So phase one, information exchange. Client sends the client hello and server sends the server hello. So with the following messages, version will be specified, client random number will be generated, session ID will be there, cipher suit will be there. Cipher suit means what is the preferable list of encryption algorithms or listed. Okay, and the compression method. So these are all the details which will be sent by the client hello by the client. Okay, and server will be responding to that. It will be comprising version, the server random number, session ID, selected cipher set. That is, among those list of encryption algorithm, it will be selected some encryption algorithms. Okay, and it will also go for selecting the compression method also. So client hello will be having the highest SSL version number that the client can support, and it will also have a it will also have a random number that will be used for the master secret key generation, and a session ID will be there. Cipher suit will be defining the list of algorithms that the client can support and the list of compression methods. So this all these message will be comprising in the client hello, which will be sent by the client. Okay, and session hello will be having session version number and random number and session ID and the selected cipher set, selected compression method from the client list. So all these details will be sent by the server to the client. Okay, so coming on to the phase one, already we have seen client passes the preferred algorithms to the server via the HTTP yes request, that is HTTP secure protocol. So the preferred algorithms may be the list of public key encryption algorithm, private key encryption algorithm, hash algorithm, compression algorithm, and also the random number for the key generation. So all these lists will be sent by the client to the server. So the server replies with the algorithms that will be used. Okay, that server will be selecting all those algorithms and passes their own random number to this client. Okay. So coming on to the phase 2, server key exchange and authentication will be done. Okay. So that is the certificate. If it is required, the server sends the certificate message to the authenticate itself. Okay. And server key exchange means it includes its own contribution to the pre-master secret. And it will also, the server will be sending the certificate request to the client also, so that the client can send this message in phase 2 for certification from client in phase 3. Okay, that is, the server can also request for the certificate to the client, so that the client can send the certificate in the next phase. Okay, server hello done message will be sent by the server to the client. Okay, this is the last message, which is a signal to the client that phase 2 is over and client needs to process the phase 3. Okay, so this phase 2, that is server identification and key exchange was being done. The server passes the certificate to the client. Okay, and also public key will be sent by the server. Okay, see here in phase 2, if no certificate containing any public key, then the separate key must be passed. Okay, see here in the first picture, if the certificate contains RSA public key, then there is no need for separate key passed. So see here in the second picture, no certificate means so Diffie-Hellman algorithm, so which is the main algorithm used for key exchange. So this is not meant for an encryption. Diffie-Hellman is meant for only the exchange of keys between the client and the server. Okay. So the server can also request for the client certificate to authenticate the client. Okay. So here first the chain of certificates will be sent by the server, and also with the public server's public key will be sent from server to client. Next process, the server also requests for the certificate from the client. Okay, so list of acceptable certificates, list of acceptable authorities will also be sent from the server to the client. Okay. So coming on to the third phase, now the clients start exchanging the keys and it will also send the certificate to the server. Okay. So the client sends the certificate message. And it includes the client key exchange includes the contribution to the pre-master secret. That is, next it will also do the verification of the certificate. The client needs to send a corresponding private key for the certificate it sends. Okay. The same thing. Now this client sends a certificate to the server and it also sends the client public key. Okay, fine. See here, what does the SSL key generation happens? There is client will be generating the pre-master key. It will be client sends to the, so client will be encrypting with the help of the server's public key. Okay, so the client and the server will be using the random, there is pre-master key to generate the master key. So pre-master secret key was generated by the client and sent to the server. So what are all the key exchange algorithms that can be used by the SSL protocols or RSA, anonymous Diffie-Hellman algorithm, ephemeral Diffie-Hellman algorithm, fixed Diffie-Hellman, and Fortiza. Okay, so these are the key exchange algorithms used. So RSA is used to generate the pre-master secret keys. which will be a 48-byte random number created by the client and sent to the server. And also it is encrypted with the server's public key and it was sent to the server. Okay. So what is anonymous Diffie-Hellman means? It is more simpler and insecure method. So there is the pre-master secret is established between the client and the server using the Diffie-Hellman protocol. Here the Diffie-Hellman half key is sent in the plain text. Ephemeral Diffie-Hellman means in this each party will be sending the Diffie-Hellman key which is signed by its private key. Okay, the receiver party will be need to verify the signature using the private key of the sender. So usually the server will be verify the signature. The receiver party need to verify the signature using the private key of the sender. Okay. And this private key are exchanged using with the help of this RSA or DSS digital signature certificates. Okay. Fortisa is nothing but an agency. It is the registered trademark of the US National Security Agency. So the protocol was developed for the Defense Department. Okay. And what are the encryption and decryption algorithms used by the SSL protocols or stream RC4, block RC2, block DES, and block IDEA, block Fortisa. Okay. So the previous slide we have seen key generation algorithms, and in this slide encryption algorithms are listed here, and the compression is an optional one. Optional in the version SSL version 3, and the default compression method is null. Okay. And before processing the generation of SSL certificate, there should be some parametric generation. So to achieve the message integrity and confidentiality, the SSL needs 6 cryptographic secret keys and 4 keys and 2 IVs means initialization vectors. Okay. So client and server each needs 1 key for message authentication and 1 key for encryption and 1 initialization vector for the block encryption. Okay. So already we have seen this procedure in the previous steps itself. No need to go along with this. Okay. And session and connections. So if you want to need to establish a session, this is nothing but an association between the client and the server. So we need to go with setting some parameters such as what are the algorithms used and session numbers likewise. To establish a session between the client and server, we need to provide the parameters like algorithms used. Okay. And connection means it's a logical connection between the client and the server link. So this is associated with the type of services. So in SSL terms, it must be a peer-to-peer connection with the 2 network nodes. Okay. And what are all these session state parameters need to be set? They are a session identifier, pure certificate, compression methods, algorithm specification, okay, and master secret, and if it is resumable or not, like it's a flag. So these are the parameters need to be set. Next, the connection state parameters need to be set or client random number, server random number, and server write max secret, that is the secret key used for the data written by the server, and client write max secret, that is the secret used for the data written by the client. Okay. Server write key and client write key and sequence number. These are the parameters which has to be set while the connection between the client and the server need to be established. Okay. And what are the four protocols we have seen in this algorithm? They are handshake protocol, and this handshake protocol is used to negotiate the cipher suit. That is, what are all the encryption algorithms needed to be use. That is, the client will be preparing the list of algorithms. Okay, that is cipher suit. Okay, to authenticate the server to client and client to the server. Okay, so this is done in 4 phases, which we have already seen. The next protocol is alert protocol, which will be sending the error message and warning message. Okay, so some abnormal things happen means it will be intimated to the peer entity. Okay, that is, the primary use of this protocol is to report the cause of the failure. Okay, so these are some of the values which denotes the description of the failure or bad certificate or node certificate. Likewise, it has been sent. It has been listed in this slide. Okay, and record protocol. It's used for fragmentation, compression, and encryption. Likewise, so these are the services which is provided by the SSL. Okay, so first thing, fragmentation means breaking down the data from the application layer with a fixed length. Okay, that is, what is the length of the data, it is going to be compressed. Okay, that is fragmented. Okay. So the fragmented data means it has been divided into blocks. Okay, so after divided into blocks, it has been set to the compression. So compressing the data will happen. Okay, so add the message authentication code, which is calculated with the help of the integrity key. Okay, so fragmentation, after that compression, after that adding the MAC code. Okay, so then we have to go with the encryption. Encrypt the packets with the help of the encryption algorithms. Next, you have to append the SSL record header. Fine. So this is the message format of the record protocol header, which comprises protocol, version, length. Okay, this is the protocol message format of the chain cipher specification protocol, which comprises protocol, that is 20, version, length. Okay, so this is an additional 1 byte field in the message, is called the CCS protocol, chain cipher specification protocol. So this will be done at the handshake protocol, because for exchanging the keys, so the default value is 1 here. The next thing, this is the message format of the alert protocol. So here you can see the level 1 byte field defines the error level. Okay, 2 levels of error means it is defining a warning as well as the fatal. Okay, so 1 byte description defines the type of error. Handshake protocol, the message format is like this. And hello request message, it was rarely used, which will be a request message from the server to the client to start a session. Okay, and this is the client hello message from client to server. This message will be sent. Okay, it comprises protocol, version, length, and type 1, and client random number, session ID, cipher suits, and the compression methods. Okay, and server hello message also, which is similar to the client hello message. Okay, so here the difference, client will be set as type as 1, and here the server hello message, the type is set as 2. Okay, so how the key generation is carried out. Okay, so the client will be generating the pre-master secret, that is PM. So this is generated by the client by applying the hash algorithm, SHA algorithm. So pre-master secret along with the hash code, and again you are applying the MD5 algorithm, you are getting the hash code. Okay, likewise all the messages you are getting altogether all the hash codes. Okay, so with the master secret key, so you are going to generate the key material. Okay, M is representing master secret. Then with that master secret key along with the encryptions, along with the data, hash algorithm is applied. So pre-secret key along with the hash algorithm is applied to get a hash code again. So all these from other data also it has to be done. Then you're collecting all the hash codes, you will be getting a key material. So here CR representing the server random number and client random number. Okay. So the key material, after collecting all the hash codes, the key material will be generated. This is used to generate keys for the encryption process and the authentication process. Okay. And it also used to generate the initialization vector for the block cipher chaining. Okay. See here, these key material is useful for client authentication, for generating the client authentication key, server authentication key, and client encryption key, server encryption key, client initialization vector, and server initialization vector. Okay. So the phase 4 is finalizing and finishing the handshaking process. Okay. So with the client, with the help of the chain cipher specification, the client sends a chain cipher specification message to show that all of the cipher suit set and the parameters from the pending state, it becomes to the active state. So then finished will be sent by the client to the server. Finished message will be sent by the client to the server. And after that, in response, the server will be sending the finished message to the server. Okay. So mainly this chain cipher specification protocol is used to chain the encryption process being used by the client and the server. Okay. So this is a single message which consists of one single byte. See here you can see the final handshake process. The client and the server will be verifying the protocols and the keys. The sender will be will do the encryption process and send the finished message, and on the other hand, the receiver will be do the decryption process and verifies the message to confirm the keys. Okay. The first picture, W is representing write, that is sending the message, and R is representing reading, that is receiving the message. Okay. See here, the first case pending, it means that it is going to yet to start from the client to server. The message is yet to start with the client to server. Okay. So the client finished the messages can be signed and encrypted by the client and verified and decrypted by the server. Okay. So first in the W, first column active, W represents these are the messages to be sent to the server. Okay. So at the server side, it is receiving. R is representing receiving the particular messages. Okay. Whatever the client sends, the server receives it. Okay. Then client and server will be sending the chain cipher specification to specify that the process of finishing the handshake. Okay. And how does the transmission of data happens? First, the fragmentation process, that is message will be broken into blocks. So the payload from the upper layer means the data from the upper layer, that is application layer, will be transmitted to this transport layer. Okay. Then after fragmentation, some compression will be carried out. The compressed block will be passed on to the hash algorithm. By applying the hash algorithm, it gets some code. So after hashing, you will get a compressed data along with the MAC, that is message authenticated code. Okay. So with that compressed code and MAC, it gets into the encryption process. So this encrypted fragment will get added onto the as a payload along with the record protocol header. Okay. So what are all the algorithms used are DES, DSA, that is digital signature algorithm, and KEA, that is key exchange algorithm, and MD5 is a hash algorithm, RC2 and RC4 reversed encryption ciphers developed mainly for the RSA data security, and RSA algorithm is used, RSA key exchange algorithm is used, SHA-1 algorithm is used, and skipjack, this is a classified symmetric key algorithm implemented in FORTISA. It's the agency, US government agency. Okay, and triple DES is also applied here. So these are the algorithms used for encryption, and hash algorithm likewise. So asymmetric key cryptography algorithm used are Diffie-Hellman algorithm and reversed Sharmer-Edelman algorithm. Okay, already we have seen the process of this asymmetric key cryptography, and symmetric cryptography means it's mainly useful for the encryption of data and transposition, substitution, and simple round ciphers. All these were used for symmetric key cryptography. And the modern round ciphers used are DES and triple DES and AES. Okay, so all these are the algorithms used for the symmetric key cryptography algorithm. So what is CA? That is certification authority. It's a agency. Okay, so there are 50 root certificate authority worldwide, and these are the agency used to list some of the certificate authorities that will be listed on the browsers. Okay, so for example, WebTrust, that is a security auditing purpose. So the certificate authority will undergo some audit purpose. Okay, will do some auditing. Okay, and this is a large authority useful for VeriSign. That is, I can go for seeing GoDaddy will be providing 23%, and Thawat and GeoTrust will be providing 48%, and Combodo will be providing verified signature like 15%, and others 14%. So these are all the authorities which provides the certificates. Next, TLS means transport layer security, which is similar to that of the SSL. That is, the extension of SSL is going to be a TLS, transport layer security. So two protocols are mainly dominant today for providing the security in the transport layer. They are SSL and TLS protocol. Okay, so TLS is mainly designed to provide security at the transport layer. So it is derived from the SSL. So SSL version 3 is it's the emergence of TLS version 1. Okay, why do we need this TLS means? So no other third party can access the message in between the transmission of client and the server. So mainly security need to be provided with the help of the TLS. Okay, so the working of TLS is similar to that of the SSL. Okay, which we have already dealt. Okay, so handshake protocol, record protocol, alert protocol, and ciphers, chain cipher specification protocol. So all these are similar to that of the TLS also. Okay, so the client connect to the server with the help of the TCP. The client can be anything also. So the client sends the number of specification like a version of SSL or TLS, and whatever the encryption list of algorithm suits. Okay, that is cipher suits, compression methods it want to use. That's the first process. So this was all sent by the client. The server in response checks what is the highest version, SSL or TLS version, that is supported by them. Okay, and picks and selects the cipher suit from one of the client supports, and optionally picks the compression method also. Okay, and after the basic step is done, the server sends its certificate to the client. Okay, this certificate must be trusted by either the client itself or the party that the client trusts. Okay, so both can happen. Okay, so for example, if the client trusts the geo addressed, means the client can trust the certificate from the google.com, because it is geo trust cryptographically signed Google certificates. Okay, and that is the working of TLS is similar to that of the SSL. Okay, so we'll see what are the benefits of two protocols, TLS and SSL. So encryption is provided, that is TLS can help to secure the transmitted data with the help of the encryption algorithms. Okay, and interoperability. So what is meant by interoperability means TLS can work with any browsers, most web browsers, including Internet Explorer, Netscape Navigator, or else it can work with any operating system also and web service. Okay. Then algorithm flexibility. It provides algorithm flexibility also. TLS provides options for the authentication mechanisms, encryption algorithms, hashing algorithms that are used during the secure session. Okay, and it is easy to deploy also. Okay, many applications will be using this TLS transparently on the Windows servers 2003 operating system, and easy to use also. Okay, and these are the slides references used for preparing the slides. Okay, thank you students for patient listening.